Hello, I'm Nimrat Ratnayaka. Today I'm going to discuss about design patterns. Firstly, I'm going to discuss about adapter pattern. The adapter pattern is a structural design pattern that allows objects with incompatible interfaces to work together. It acts as a bridge between two incompatible interfaces. Suppose you have system that processes university student data. Suppose that system now process student university student data only. You can see this university student class implements student interface. That means each university student have these three behaviors. And also there is another class in here. We use it to create a list that contains student elements. Now you suppose you want to integrate this school student class with this system, but you can see inside of this school student class there are three methods, but they are a little bit different from this student interface. um, um, uh, Therefore, because of that, we can't add this school student objects that we created using this school student class to this list directly, because this list contains student elements. School student objects are not compatible with student interface. This is the problem. To solve this problem, we are using adapter. This is the school student adapter class. It implements this student interface. We can use this school student adapter class to add this school student objects to this list. Um, this school student adapter make it this school student class compatible with school student interface. Now let's move to the code. This is the demo class in the system. You can see there is a class called as student client class in the system. In here, we are creating a new object using this student client class. In here, you can see there is a method called as get student list. Now, let's see what is going on inside of this function. This is the student client class. In here, we are creating a new list. This list contains this student elements. This is the inside of this student interface. There are three methods in here. It means this each student have these three behaviors. Now let's move to the previous code again. In here, you can see there is another class, university student class. In here, you can see this university student class implements student interface. It means we must override these three methods that we use in student interface. And also there are three variables in here, three variables declared in here. This is the construct of this university student class. In here, we are passing three variables, and in here we are assign them to this instance variables that we declared in here. Um, Now let's move to the previous code again. This is the student client class again. In here, you can see there is another class, a school student class. Inside of this school student class, you can see it not implement a student interface. There are three methods in here. You can see they are a little bit different from student interface methods. Now let's move to the previous code again. In here, we are using this university student object that we created in here to add to students list. we can use this object directly in here. But let's uncomment this. You can see there is an error in here. We can't use this school student object that we created in here directly. We can't add it directly to the this students list, because this school student object not compatible with student interface. This is the problem. To solve this problem, we have to use a adapter. Um, this is the inside of school student adapter class. This school student adapter class implements student interface. It means we must override these three methods. In here we are declaring new variable to create a new instance, school student using school student class. uh, um, Now let's move to the previous code again. In Now we can use this school student object in here. Um, uh, now we can add this school student object to this students list, with the help of school student adapter. In here we are creating a new instance using school student adapter class, and passing this school student object as a parameter. Now let's see the output of this code. Uh, this is the output of this code. It gives us university student object as well as school student object. The problem is solved. This is all about adaptive design pattern. Now let's move to the singleton pattern design pattern. Um, The singleton pattern is a creational design pattern. It ensures a class has only one instance, and it provides a global access point to that instance. Imagine we are building an application that needs to write login messages to log file. So we want to make sure there is only one logger object in the whole application, because if we have many logger objects, um, uh, these multiple objects can write messages to log file, and at the same time it can get messy, and it can cause more memory usage. And to solve this, we use something called as a singleton. It is like having only one instance, only one special logger that everyone shares. We can have only this logger object to write to the log file. Now let's move to the code. Uh, in order to implement a singleton logger class in Java, first of all, we should make the constructor private, because if the constructor is a public one, we can use this constructor, and make create many objects directly in anywhere. Um, as the second step, we create a private static variable to hold um, the single instance of the logger class. As the second step, we are creating a method to um, get the instance. In here, um, this method returns a single instance of the logger class. If no instance exists, it creates one and returns it. If an instance already exists, it simply returns that instance. In here, this log method, we are using this log method to log messages to the log file. Um, this is the main method, main class. In here, we are creating two instances. Um, we can't use constructor to um, create a new instance because now constructor is a private. Because of that, we are using in here uh, this get instance method. In here, um, we confirm whether logger 1 and logger 2 are referencing the same instance by checking if logger 1 equal logger 2. When you run this code, this is the output of this code. It returns true um, because logger 1 and logger 2 are referencing to the same instance. So the singleton pattern ensures that the class has only one instance and provides global point of access to that instance. Um, that is all about singleton pattern. Now we move to the mediator pattern. This mediator pattern promotes loose coupling by um, allowing objects to interact with each other through a mediator rather than directly communicating with each other. Imagine we have chat application when users communicate with each other. However, sending messages directly to each other can lead to tight coupling. To solve this problem, we introduced mediator interface called chat mediator. This interface declares methods for communication between users. Let's walk through this code. This is that chat mediator interface. It has these two methods. Uh, this is the chat room class. It implements this chat mediator interface. It means it must override. We must override these two methods that we used in this chat mediator uh, interface. In here, we are declaring a new variable to hold to we are in here we are uh, declares a private list to keep all users. In here we are initialize the users list as an empty list. Uh, uh, this is the user class. This is a abstract class. Since this is a abstract class, these methods should be abstract methods. Um, in here we are uh, declaring two protected variables. Uh, and in here we are initialize to, those two uh, variables variables mediator and name. Um, um, this is the concrete user class. It extends user class. Because of that, we must override these two methods. In here, this is the construct of the class. Construct of this class. In here, we are passing these two parameters, and we are calling the super class. That means user class. User class as constructor to set up the mediator and name fields. Now let's look at the output of this code. This is the output of this code. In here we um, simulate message exchanges between users. Each user send methods calls the mediator to distribute messages to all other users, demonstrating the mediator design pattern. According to this output, you can see The purpose of this code is create a chat application where users can send messages to each other without directly connecting to each other. Instead, they use a central mediator. They use a central mediator called chat room. This is all about mediator design pattern. Um, this is the end of my presentation. Thank you for listening my presentation. Thank you.